Hello and welcome back. The saga continues on the 2C34 amplifier. Some changes have been made and some progress made. Here's the what do you call it? Cathode follower, constant current source and control grid circuit board. Looks a bit empty, but there's loads of stuff surface mounted on the bottom, and that is the circuit that I showed you the other day, which is a bit mucky now. You can't really see it, but that's that and that combined, and that will sit in there like that. So they go to these two 470k resistors, go to our control grids, which is here and here, and this wire that I'm going to solder in a minute will go to our two MGE 340s. The two MGE 340s, as you see, have got 10 ohm resistors from the collectors to the cathodes. Yeah, from the collectors to the cathodes. That's just there at the moment, just so I can sense the current. So we should, 10 milliamps is what? 10 by 10 should be 1 volt, or is it 0.1 volt? I don't know, something like that. It's a bit early still. Anyway, I'm going to solder that up. Put the 6 BL7 in. Make sure the voltages are right. Then I shall plug the 2C34 in. Only then, when that is sorted, can we progress to the rest of the amp. The rest of the amp should take an afternoon, should be pretty straightforward. Anyway, onwards and upwards. Okay, first power up. I've noticed, just checking voltages, that I wasn't powering it all the way up, I'm just powering up on a variac. I had minus 44 volts here and minus 25 here. I've been caught out before with these MGE 340s in that I've had problems with the sill pad. I forgot to put a sill pad on the sill pad on the 6146 amp, which then obviously grounded the collector. Sorry, I keep getting mixed up with cathodes and collectors. And then obviously that buggered our cathode voltage up. So, trying to find out what the crack was, I loosened that to see if that was the case. No, it isn't the case, but one thing I did notice was that when I started taking the base voltage, I noticed we've got a bit of a short to ground somehow, sort of an intermittent ground connection. So the board's going to have to come out and just have a quick look underneath there to see if I've got a solder bridge or something like that. I checked it before with a magnifying glass and went over it, but I couldn't see anything, but obviously I've missed something. Ooh, one other thing, these 820 mic, obviously because it's, they're in parallel, there's some like 1640 mics of capacitance there. At 300 volts, that's a lot of bleeding energy. I forgot to put a bleeder resistor across them, so which might be a good idea, because what I've been doing is using my discharging thingy. That's just a resistor with 2 bits of bloody copper and a bit of wire. Using that to discharge the capacitors, we get big blue sparks. So I think we need to stick a drain resistor, bleed resistor on these even, so that would be a good idea. Safety. Right, after mucking about, I tested all this. I did find one fault, but it wasn't associated with the constant current source for the MGE 340. I had the same voltage on the emitter and on the base as this MGE 340 here, but on the collector I had something like 5 volts less. So after farting about, I pulled another MGE 340 off the prototype there and That seems to be okay. So okie dokie, everything's working okay. We've tacked in a 180k across the power supply, HT power supply, to give us, that's a bleeder resistor, to save taking the board out here. On our, we've got the 6BL7 in there. On the cathodes we have, oops, sorry, minus 19 on one, wait, minus 19 on the other one. You have to take my word for it. You adjust what's on the cathode and therefore which will be on the grids of the 2C34 by adjusting these two pots, which adjusts the voltage going to the control grids of the 6BL7. So I'll wait for the voltage to go down, pop in the 2C34, and we should be cushy. Obviously I've got to solder some wires across from one to the other. There's a good one for you. I've just spent the last 10 minutes trying to find out why I've got no HT and why I've got no bias voltage. I looked at the bloody transformer, I tested the fusers, pissed about, thinking what the bloody hell, I've got voltage there but not voltage there, what the hell is going off? And then I realised that I'd knocked the bloody main on switch. 680R for the cathode resistor, and then we've got two 47Ks for the cathodiene phase splitter. And then what have I got there? I've got 4K7 and a 680 ohm resistor in series to bias the cathodiene phase splitter. And this is where I think it's wrong. These are our DC conditions, so let's see which is a cause for concern. A little bit cause for concern is there. Bias is 76 volts, so that needs to go up. That's okay because I put an extra winding on the transformer. I've got two extra windings of 15 volts. So that's okay. These are the DC conditions for B1. Anode 116, grid 0, cathode 2.5. That I would like to have been a bit higher, but still, it's still okay. Well, here's where I think it starts going wrong. If this is right, anode and that means we have got 24 volts, minus 24 volts bias. This means this is biased way too low. We should be looking at more minus 8 volts, not minus 24. This is where I think we fuck up. Out of V1 we've got 13.4 volts RMS coming out, and then basically V2 is acting as a de-amplifier. We're getting less out, we're only getting 10.3 volts out, and that's because it's biased wrong. Cathodiene, as far as I know, should be unity gain, or a little bit less than unity gain, so if we're putting 13 volts in, we should be getting 13 volts out. Let me just turn this off. These here, the cathode follower is good. The output valve 0.26, that's 26 milliamps. 26 milliamps. Bit low, we could bung that up a bit. Bias that a little bit hotter. This is where we're fucking up here. So I've got to now do some calculations. Well, here we are the next morning, and I'm testing two things. I'm testing the ripple on the power supply. What I've done, I've taken one of the 820 microfarad capacitors off. The transformer just can't supply enough current. The other thing I'm testing is an input transformer This solves a problem. It basically boosts the input. However, like with a lot of input transformers, there's a problem with frequency response. This came off an old Shaw mixer. It's designed for microphone use, so let me just give you an idea of what the crack is. Frequency 1 kilohertz. You can see that we're all good. Right, let me put in 100 hertz. Frequency 100 hertz. Still not too bad. Still about the same amplitude. Frequency 20 kilohertz, and as you can see it drops off a cliff. Frequency 10 kilohertz, still not brilliant. Frequency 5 kilohertz, yeah, it's still less than what it was at 1 kilohertz, so that's no good. We can't use that. And then we've got a problem with our where are we? Just sort of, so that's the ripple on our power supply on a HT. I'll make that about 150 milliamps, sorry, millivolts, 150 millivolts, which is no good. So we're going to have to rethink the power supply and rethink the front end. Let me just turn this off. I wanted to use these valves because they look good, but at some point you have to consider whether we should sacrifice a little bit of artistic sort of loveliness for operational, what do you call it? Sorry, I can't think of the right bleeding word. It's alright it looking good, but it's no good if it don't freaking work. So what could we do? We could swap the DET22C22 for a 6SN7, connect that to a constant current source and make it a long tail pair. That might solve the issue. We could swap the front end out for a pentode, something like a, I've got some, what are they, let me just think, what the frick are they? EF37s, A's, you know, the big red job is. Could do that. Or we could stick an op-amp buffer booster on the input. I'm going to have a think about that one. After looking at the power supply design side of things, we're going to have to use this choke. It's just not practical to use big massive capacitors, unfortunately. I thought that would be the case, but hey ho. So as you can see, I took the top plate off and the two clampy bits, and the core came away real easy. I was surprised at that. I thought they'd be interleaved, but this is a bit different, this one, in that it has T and C's sort of laminations. I've got to remember where these go. There is a bit of cardboard there and a bit of corresponding cardboard on the other side to stop the core saturating. So what I want to try and do, unfortunately that's buggered that sort of nice sticker of Birmingham BSR sticker, but fuck it, it can't be helped. So one thing I wanted to do is to replace this with something obviously better, whilst taking very, very great care not to snap the freaking wires off. So I'm going to do that and just try and clean it up a little bit, and then the other thing I want to do is to cut these feet off, and then what I plan to do is, well, you'll see what I plan to do later. Instead of mounting it so it stands straight up on end, pardon me, rattling a bit here, sort of put it that way, so that will lower the footprint while also orientating the laminations 90 degrees away from the output transformers. So with this 25 Henry choke and two 220 microfarad caps, we should have nice smooth HT, which the transformer can handle hopefully. Right, I'm going to go and try and get that cleaned up the best I can without breaking the wires. More later. Here we are again, 234. Changed the caps to 220 microfarads instead of the 820. We've put the choke in. I've altered the choke, made some sort of temporary feet. That's just popped in there temporary for the moment. Everything's wired up. Big massive jumble of wires. Here's our trace on our here's our trace on the HT B+. No ripple, as you can see, all those spikes are gone. Jumping up and down a bit though, isn't it? Here's the meter reading, 297 volts. I'm just on the variac, so it's a little bit low at present. And here's our ripple. Before it was 150, wasn't it? 150 millivolts. No, it's about 10 millivolts. Hell of a lot better. So, everything's good. That's the power supply sorted. Obviously I've got to mount the choke on the top there. It needs painting, but everything's got to come off at some point anyway. Chassis and whatnot to be painted once I've done messing about with it, drilling holes. So the next issue to solve will be the gain, boosting the gain somehow. How I'm going to do that, I'm not quite sure, but we're getting there. It's not oscillating, it's not jumping about, it's not playing silly buggers. Right, well, I think we'll cut this one here. That's enough rabbiting on for one video. Thank you all very much for watching. Take care of yourselves, and ta-ra for now.